Hello, pre-calculus students and seekers of truth. We continue our study of polar functions with this example here. And this polar function is going to produce a pretty looking flower, but we want to analyze mathematically and also be able to understand how this flower gets created. All right, so let's start with some things that we know. The domain here for most of these functions, especially if we're using sine and cosine, is going to be all real numbers. We can plug in anything that we want for theta, will not break the function. The range here, and remember the range is the possible values of r, or the radius. Well, the sine function, even with this transformation, will produce a number between -1 and +1. All right. And then let's talk about the maximum r value, or the maximum distance from the origin. Well, the biggest number, the farthest that we could get away from the origin, is 1. Right? There's no doubt about that. Now here, let's talk about the minimum. What's the minimum value of r? Well, again, remember that, let me scroll back to what we talked about before here. The r values, when we're talking about them, we're talking about the distance, right? So how far can we possibly get from the origin? And you can see that in here, in this range, the number that's closest to the origin is actually 0. So it's actually possible for us to have an r value of 0, and that's going to be the distance closest to the origin. We could also have an r value of a negative 0.5, -1, but all of those have a distance farther from the origin. All right. So let me clarify, this is the minimum r value. Okay. And then let us as well start with a graph of this, and then we can sort of analyze and pick it apart in just a little bit. All right, so I've used a graphing tool to produce this graph, and clearly this rose here is going to have 4 petals, but I want to be able to do some analysis of this so that we can determine the number of petals and how the petals appear, even if we don't graph. All right, so one of the things that we can notice here is that the rose petals, they have points that are the max r values. Okay, so from this distance here to here, this blue line here is as far away from the origin as we can possibly get. This distance here is also as far away as we possibly can get, and so is this distance, and so is this distance. Okay, so I want to say one thing, that for theta between 0 and 2 pi, certainly if we just keep on graphing forever and ever, we'll just go around in circles. But at least from theta between 0 to 2 pi, we have there are 4 max, or I should say the maximum r value, the maximum radius, occurs 4 times in those 4 particular dots. And let's try to understand a little bit more what those points are and how can we find them. Well, the max radius we know is going to be 1. Okay, the max r value is going to be 1. So one of the ways that we can describe this is that the radius is equal to 1. So let's solve for theta. Well, if you think back to our unit circle, the sine function is equal to 1 when you have pi over 2. Okay, so unit circle now, and I'm drawing a lot of pictures, but the unit circle up here at this point, this is 0, 1, right? The sine function is the y value, so sine is equal to 1 when you have theta is equal to pi, when the angle is equal to pi over 2. But in this case, we have the input to the sine function is 2 pi, so we solve for this, we get pi over 4 is equal to theta. Now, this is not the only solution, because this function here has a period of pi. Right? Normally the sine function has a period of 2 pi. Now we have a period of pi. So the other theta value we could have here is pi over 4 plus pi, or 5 pi over 4. Okay? So that means the r value, the polar coordinate point that we have, occurs when r equals 1 and theta equals pi over 4. Occurs when pi is equal to 1 and theta is equal to pi over 4. The second point that we have is when r is equal to 1 and theta is equal to 5 pi over 4. So that's these points right here. In polar form, this is 1 pi over 4. Over here, this is 1, 5 pi over 4. Okay? And so just by knowing this information here, we can actually determine some features of this graph. Okay, well, what about these points? Where do these points come from down here? Well, let's think about it another way, that the maximum r value is 1. That can occur when the radius is equal to 1 or when the radius is equal to -1. So we can set up a similar problem and say -1 is equal to sine of 2 theta. Sine is equal to -1 at 3 pi over 2. And then divide both sides by 2, and we get that 3 pi over 4 is equal to theta. Okay. Now keep in mind the period of this function is pi, so we're going to get another point at pi plus 3 pi over 4, or 7 pi over 4 is equal to theta. All right. So what do we have here? Well, the other coordinates, the other points that we might be able to identify here is that when r is equal to -1 and theta is equal to 3 pi over 4, or when r is equal to -1 and theta is equal to 7 pi over 4. Okay. And let's see where that applies. Well, if you go out here, that's -1, and we rotate yes, that's right. If we go out here, -1, and we rotate (3 pi over 4), we actually get to this point right here. Okay, so this is -1, 3 pi over 4. And then if we go out -1 and 7 pi over 4, so this is 1 pi over 4, 2 pi over 4, 3 pi over 4. This is pi right here. This is 5 pi over 4. 7 pi over 4 is actually right here. So I realized I actually made a mistake in my previous problem. This point right here refers to, this should be -1. Come on. This is -1, 7 pi over 4. Okay. The other point that we talked about, +1, 5 pi over 4, is this one down here. This is +1, 5 pi over 4. Okay. So these are where the 4 maximum points occur. And again, we're talking about, there's a couple terms that we're throwing all over the place here. Max R value is talking about the distance. R by itself is just talking about the radius. So the radius could be positive or negative, but the max R value is talking about the absolute distance from the origin. And based on these information, we can figure out some features of this graph and then use a graphing calculator and identify that this is in fact going to have 4 petals on this rose. And the length of each of these petals is going to be 1 because that's as far away from the origin as it can possibly get. As always, keep working hard, keep fighting the good fight. If you have a hard time and need clarification, ask for it. Thank you for watching and have a wonderful day.